I'm Alex Barnhill. These are my fellow classmates.
I'm Will. Christian.
Austin. Jacob.
We're students in the Computer Integrated Machining Technology program at Nash Community College. In the MAC 248 Production and Procedures class, we learn how to take a project all the way from an idea to a finished product. This year's class capstone project was building a scale replica of one of the main focal points on our campus, the Julian B. Fenner Memorial Clock. Our design process started out with a type of CAD or computer-aided drawing software called SolidWorks. SolidWorks allows us to take the idea from a rough sketch to 3D models. The next step we used was a computer-aided manufacturing software called Gibbs Cam. Gibbs Cam allows us to define our tools and simulate how the part will run in the machine without damaging the machine or tools. Our project started out focused on the clock head. We started here based upon available clock faces. Once we determined the size of the clock face, we could scale the other parts accordingly. With the clock head being the focal point, it was important to get the correct curvature and shape. The Gibbs Cam software allowed us to make sure radius and angles blended properly and that parts could be machined as designed. Just because you can draw it doesn't mean it can be machined. We incorporate the 5-axis capability of the Haas VF3 CNC mill. We built a fixture to work off the turntable and created a standoff for the clock head blank. This allowed all the milling and intricate detail to be done in one setup. The 5-axis permits the proper movement to achieve the continuous flow of radiuses and blending of the different milling processes. Whereas the head has a lot of intricate detail, the base had some very obvious detail. The base was one of the two project parts that incorporated the use of our new robotics cell. This was done in conjunction with the ATR 281 robotics class. Both classes learned what works for one doesn't always work for the other. The important component is the use of the robot allows for unmanned and unsupervised continuous running of parts. The first detail on the base is the raised outline of Nash County. This consisted of importing a drawing and converting it to a raised component of the base. The other design feature was the engraving of the Nash Community College logo. This and the Nash County outline are the two main features of the base. The integration between robot and computer numerical control machine proved to be a valuable learning experience. One that will be valuable to our students as they move into industry jobs. The post, while small, carries a lot of detail. The detail goes from the taper on the post to the square on the base. There are intricate features on the square base matching details on the actual clock. The tapered post has a fluted detail. This feature requires working in several different planes and angles of rotation. Although it's the smallest part on the clock, the finial could possibly be one of the more important parts. With its visible location atop the clock, it's one of the first parts seen on the finished product. It was important to be spot on in our execution of the finial. The finial is also manufactured in the robotic cell. The part is machined to leave the finial attached to the stock and allow the robot to break it off and deposit it in a bin. Once all the parts were machined and checked for fit and finish, they were sent to a local company for a finishing process called anodization. To anodize is to coat a metallic surface electrolytically with a protective or decorative oxide. And in our case, we chose black. Once back from anodization, the assembly began. The manufacturing and execution of our design showed its true measure, a completed assembly.
150 clocks seemed quite the daunting task. With more than 2 hours of runtime in each completed clock and countless hours of preparation, we reached our goal in the allotted time of 1 semester. With a visit from U.S. Senator Kay Hagan coinciding with the completion of our project, our class was able to present her with our first assembled clock, a great way to introduce our clock to the world. We'll see you on our next project here at Nash Community College.